Now we take a look at factoring a cubic polynomial, and in this case we will have to use a rational zero. So we start by looking at this and we think, oh, there's 4 terms, let's try grouping. I'm going to save you the headache here. You should try it if you can't tell why, but try it and you'll see that grouping doesn't work. Okay, so that's our standard technique. Grouping doesn't work. So try that, see why it doesn't work. Alright, now grouping doesn't work. There's no, actually there is a GCF, so we could pull that out. So we could pull a 2 out, leaving 2x cubed minus 7x squared plus 22x plus 13. And again, you know, this guy right here, this 4 terms, grouping doesn't work. We still try our standard techniques, it doesn't work. So now the only option we have, since we can't even tell what a 0 of this cubic piece is, we have to look for a 0. So we look for, the only tool we have to help us with that is looking at the rational zeros. So potential rational zeros, let's make a list. So the numerators could be factors of 13, which are plus or minus 1 and 13, and on the bottom the denominators are the factors of 2, which are plus or minus 1 and 2. And so our list becomes, if I have a 1 on top, I could have plus or minus 1 over 1 or plus or minus 1 over 2. And then if I have a 13 on the top, I could have plus or minus 13 over 1, which is just 13. And if I have a 13 on top with a 2 on the bottom, that would be 13 over 2. So I have 8 potential rational zeros that I need to check. And the way to check them is to plug each of those into this polynomial to see if any of them are zeros. If you find one, which negative 1/2 is a 0, okay? I've already checked it, you should verify that. Negative 1/2 is a 0, which means that x plus 1/2 or x minus negative 1/2 is a factor. So what we should do, divide by x plus 1/2, and we do that with synthetic division. So we have the 0 for x plus 1/2 is negative 1/2, and I need to divide this guy here by it. So that's going to be 2x cubed negative 7x squared plus 22x plus 13. So all I'm doing is dividing this guy by x plus 1/2, which is represented by 0, negative 1/2. So to divide, I'm going to drop my 2 and start multiplying. So negative 1/2 times 2 is negative 1. Negative 7 plus negative 1 is negative 8. Negative 1/2 times negative 8 is positive 4. 22 plus 4 is 26. Negative 1/2 times 26 is negative 13. And 13 plus negative 13 is 0. So what this means now is f of x equals 2, I'm going to keep my 2 here, times the green thing, but the green thing I've just broken down to be this times x plus 1/2. So we have x plus 1/2 times what's left inside here, which is 2x squared minus 8x plus 26. So the green thing above I've factored now because I found a 0. I knew how to factor it. So now I need to factor this guy because it's quadratic. And to factor a quadratic, I set it equal to 0 and solve it. So see how once I found one rational 0, I divided to now get something even smaller. So I went from an x cubed polynomial to an x squared polynomial, and now this is quadratic, which is a good stopping point for this process, and set equal to 0. Okay, so let me work on this. So I have, sorry about that. Let's set this guy, the quadratic, equal to 0 and solve now. I'm going to do this by completing the square, and to complete square I'd like this to be a 1 in the front, so I'll divide both sides by 2, which gives me x squared minus 4x plus 13 equals 0. Then I'll add my 13 or subtract my 13 over, and then I need to make the left side a perfect square by adding something, and then keep the equation balanced. And x squared minus 4x can be obtained by getting x minus a 2 and another minus 2, which makes this a positive 4. Negative 13 plus 4 is negative 9, so I have x minus 2 squared equals negative 9. By the way, I'm going through this really quickly because I'm assuming you already know how to do all of this. This isn't the point of the video to teach you how to do this. Take the square root of both sides. The square root of negative 9 is 3i, so I've got plus or minus 3i, and then add my 2. So what I have is 2 plus 3i, that's one of my zeros, or 2 minus 3i. Okay? So let's keep those in mind. If I come back up here, the zeros of this guy are 2 plus 3i, 2 minus 3i. Okay? So let me erase this work down here that I used to figure that out, just because we're running out of room. So now I have 2 times x plus 1/2, and 2 plus 3i gives us a factor of x minus that, and this gives us a factor of x minus that as well. So I simply have x minus 2 plus 3i as one of my factors times x minus the other 2 minus 3i. And then you've got to pay attention here. Notice that this stuff here, there's no way that could equal this, right? If you were to multiply this out down here, what we just got, your first term would be x times x, which is x squared, but I need a 2x squared. So we already know that you can put any constant in the front and it won't affect your zeros or your degree. So I'm going to put a 2 here because I know that my leading coefficient there had to be a 2. So this may be the trickiest part of the video so far, but you just have to make sure that your final answers, your coefficients have to match, especially your first coefficient. If you match your first coefficient, all the others are guaranteed to match. So our final answer for f of x now, because I've got 2 times x plus 1/2 times 2 times x minus 2 plus 3i times x minus 2 minus 3i, it's all multiplication. I can rearrange it however I want. So I just end up with 2 times 2, which is 4, times x plus 1/2 times x minus 2 plus 3i times x minus 2 minus 3i. And now, if we, let me clean some of this up here, get rid of all this stuff in between. And just focus in on our answer here. What we have is the factored form of f of x, and if we just look at it and see if it makes sense because if I were to multiply all of this out, my first term would be 4 times x times x times x, which is 4x cubed. So I know that I've gotten that part of it right, and nothing seemed strange as we went through the whole process. We found all of our zeros and things appropriately. So we have now factored 4x cubed minus 14x squared plus 44x plus 26. We had to first find a rational zero. That gave us this x plus 1/2 factor, and then we had a quadratic remaining, which we factored by setting the quadratic equal to 0 to get the two zeros. And all along the way we just had to make sure that we got the right coefficient in the front, and we certainly did.